So in this lesson, what I'm going to start talking about is arc length. And the reason we're going to talk about distance first is because they are kind of related to each other. So I'm going to go ahead and just start off by explaining what is distance. Now, distance is essentially a one-dimensional measure. It measures the length. It measures how far you travel from one place to another, okay? So one of the things you probably learned way back in the day when you were in geometry and Algebra 1 was the distance formula, which looks something like this. The square root, big square root, of x2 minus x1 parentheses around that squared plus y2 minus y1 parentheses squared. Now, notice that all that's under the square root, and one of the things I wanted to make sure I mentioned to you is if you decide to try to type this whole thing in a calculator, make sure you put an extra set of parentheses at the beginning and at the end so that your calculator remembers all of that stuff is under the square root together. Now, that's a big deal when I teach it in some of the lower grades or to some of the younger students. But for you guys, it's not such a big deal that you put parentheses around it. Just make sure that you remember all of that goes under the square root together, okay? So now that I've got that written out, what I'm going to go ahead and talk about real fast is a little bit more about what distance actually means. So let's think about this again. It's a one-dimensional measure. So one dimension meaning just has one measurement. It's how far I travel from one place to another. So essentially, it's how long is this line right here. Now, the way we get this formula is it's actually the Pythagorean Theorem. So for instance, if I were to draw myself a nice little pretty right triangle here, A would be this side, which tells me the distance between the two x values. So x2 minus x1, that distance. B is going to be my distance between the y values, y2 minus y1. And the thing I'm looking for here, I'm going to call C because that's my Pythagorean Theorem, but it's actually representing the distance for D. So a squared plus b squared equals c squared, but then you still have to square root it. So a squared plus b squared, and then square root it, you get your distance. So that's the thing here is, in this case, what we're looking for is the distance between those 2 points, the length of that straight path, that straight line. And so that leads me into the next part is what is a geodesic? Well, the geodesic is actually a pretty straightforward thing. You probably haven't heard the word before, but it's okay. So the geodesic is actually the path of shortest length, okay? Now, in every geometry, no matter whether it's curved geometry or straight geometry, Euclidean, non-Euclidean, hyperbolic, elliptic, it doesn't really matter what math, what geometry you're looking in, the path of the shortest length is really always a straight line between them, okay? So that's the thing, is no matter what you're looking at, a straight line represents a geodesic. It's that distance. It's the shortest length. So for instance, this right here, C, is gonna be my geodesic. It's that path that takes me from one place to another. Now, in this case, what I want to talk about in this whole lesson, not just this video, is we're going to start talking about arc length. So for instance, what happens if I can no longer? What happens if I just plain can't take that path of shortest distance? Like for instance, what if there was, I don't know, maybe let's say a lake or rock or something that was preventing me from just traveling straight from one place to another? Well, that's the thing. The shortest length is still the straight line connecting them. It's still connecting those 2 places. However, I might have to take a pathway that goes like this. And so how far will I have to travel then? So make sure you understand this. Distance and geodesic are representing a straight path. They're representing a straight line from one point to another. But what we're going to talk about now is arc length. What happens when I cannot travel that path? What happens when I have to take a slightly different pathway to where I want? So what I'm going to look at now is the distance between 1, 4 and 3, 4. Now let me repeat again. This is going to give me distance. It's going to give me the geodesic. It's just going to be connecting those 2 points together by the straightest or shortest path. So I'm going to look at 1, 4, which is right about here. And I'm going to look at 3, 4, which is right about here. Well, if you think about it, the distance between those 2 points is not actually going to be all that difficult to calculate. Because here's the thing. The y values are the same for both of those points. All I have to worry about is the change in x's. Well, if I just look at the picture, it's 1 spot, 2 spots. The distance is 2 from those 2 points. Now, the question is, if I don't graph it, if I just use the straight algebra method, will I get the same answer? And the answer is, of course you will. So I'm going to use that exact algebraic form up there. I'm going to write x1, y1, x2, y2, and I'm just going to do the math. So d equals big square root of x2, which is 3, minus x1, which is 1 squared, plus y2, 4, minus 4, parentheses squared. Now, 3 minus 1 is 2, okay? And then we're going to end up squaring it. 4 minus 4 is 0, and we're going to end up squaring it. Hopefully you guys are doing this math in your head. 2 squared is 4, 0 squared is 0. Add them together, you get the square root of 4. which is just plain 2, which is what I had before. So sometimes drawing the picture does simplify the issue a lot because all I have to do is count. However, I'm going to look at example 2 where you cannot just simply count. You can't just find the answer just by counting immediately. So it's talking about the length of a straight line of y equals 3x minus 1, and we're going to find it between x values of 0 and 4. So I'm going to go back and try to sketch myself a little bit of a picture. It's not going to be the best picture, but, you know, we'll do the best I can. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so here's negative 1 where it starts. Because if I plug in 0, 3 times 0 is 0, minus 1 makes negative 1, so there it is. And then 1, 2, 3, 4. Again, straight line. Y equals 3x minus 1 is a straight line. So what I'm going to do is I'm going to go ahead and 1, 2, 3, 4. And then it's going to be up at 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I miscounted one. Yeah, I miscounted the first time. All right, so it's right about here. So essentially, I want to figure out the length of this line that I just drew. Now notice I didn't extend it because I really only care about x's between 0 and 4. So the question is, how far is that distance? Well, I can do it 2 ways. I can either do the Pythagorean theorem like I did before, or I can plug it into the formula. Well, here's the thing. Pythagorean theorem is actually pretty straightforward on this. I always love drawing pictures because they make my life easy. The distance between 0 and 4 is 4. The distance between negative 1, which is my y value at the bottom, and positive 11 is 12. So really and truly, all I have to do is 4 squared plus 12 squared, and that's going to give me my distance. Whoop, I wrote a square. That's just going to give me my distance. So here's what I'm going to do. Instead of plugging into this big long formula, I'm just going to do Pythagorean theorem. So you see me doing it another way. So 4 squared plus 12 squared equals d squared, or we can call it c squared. Doesn't really matter. 4 squared is 16. 12 squared is 144. Add them together, you get 160. And then you need to square root 160. And that should give me, let me go ahead and check just to be sure. 4 squared is 10. Or I could write it as a decimal and write 12 point, I'll round it off, 65. All right, so there we go. There's the distance. There's that length between them. I will also make sure I mention before I get too far because I know I'm going to need it later. Oftentimes, instead of using D for distance, we'll use S for arc length. That's just an important fact we'll come back to again later. But hopefully this helps you guys better understand what we're getting ready to get into. But this is, again, talking about the path of the shortest length. It's talking about the distance along a straight line. So when we come back, we'll start talking more about arc length. All right.